So, contact forces. Contact forces. Contact force. Pressure. Pressure force term. Pressure force term. Pressure force term. So we consider a cube, a cubic fluid element with the same volume delta V. Delta V equals delta X times delta Y times delta Z. This is our fluid element or control volume. Okay. This is delta Y, the dimension in the Y direction, delta X, the dimension in the X direction, and delta Z, the dimension in the Z direction. Delta Z. Next. Okay, to compute pressure forces, we will look at the top and bottom faces. And the surface area of these two faces is delta S, which is delta X times delta Y. Sorry. Delta X times delta Y. Delta X times delta Y. So, and the surface vector on the top face outward, while the pressure force points inwards the fluid element. Okay. Sorry, I just want to show where the surface vector is located. This is delta S surface vector, and the pressure force points inward. This is the pressure force, and for the bottom face, the pressure force upward the fluid element. Okay, so now let's derive the pressure force on the top face. So at the top face, at Z plus delta Z, this phase. So, sorry, before deriving this force, I want you to keep in mind that pressure is a normal is defined is a normal stress defined as a force per unit surface area. So pressure is a normal stress defined as a force per unit surface area. That means the pressure force delta of P equals P pressure times surface vector. And then at Z plus delta Z, pressure force delta F sub P top, this is for the top face, equals pressure evaluated in X, Y, Z plus delta Z times delta X delta Y, which is the surface on the top face. And so, but we can notice that the pressure force is opposite to the surface vector. That means there is a minus sign here. So for the bottom face at Z, the pressure force delta of sub P bottom to bottom equals the pressure force evaluated in X, Y, and Z times delta X delta Y. So the total pressure force in the Z direction is delta of P and Z direction equals the sum of the two contributions, equals delta of top plus delta of bottom, which is pressure evaluated in X, Y, Z minus pressure evaluated in X, Y, Z plus delta Z plus delta Z. Okay, since delta Z is very small, we're going to expand the pressure evaluated in X, Y, Z plus delta Z using using a first order Taylor series. So you can write pressure evaluated in X, Y, Z plus delta Z equals pressure evaluated in X, Z plus partial P over partial Z delta Z. And now we're going to substitute in the expression of the total pressure force in the Z direction. Then delta F sub B Z direction delta X delta Y Z minus, we substitute this expression by this one minus pressure evaluated in X, Y, and Z minus partial P over partial Z delta Z. And the total pressure force becomes the of this direction minus partial P over partial Z times delta X times delta Y times delta Z. And this is the volume delta V. So the total pressure force per unit volume in the Z direction is F Z direction was we divide by the volume delta V. Over delta V, which is minus partial P over partial Z. Partial V. So by symmetry, similar contribution exists in the Y and X directions. So we can write the total pressure force in X direction is minus partial P over partial X, and the Y direction minus partial P over partial Y. So combining all the three directions, we can write the total pressure force total pressure force equals minus nabla P, which is minus partial P over partial X minus partial P over partial Y minus partial P over partial Z. Okay, so let's move on to the viscous forces.